Okay, this is a review for your quadratics test, probably the toughest test that you've had in math this year. Lots of little twists and turns. Got to make sure that you are paying attention and doing well today, and then at your review tonight, and hopefully then the test will go right tomorrow. Okay, to begin with, if you are just asked how many solutions, notice it doesn't say what is the solution, how many solutions. You have to be able to say, oh yeah, I know what to do on that kind of problem. If you don't, you need to get it in your notes right now. All right, would you please write down the one word? There's a one-word answer. There's a thing that tells you how many solutions this thing would have. It's called turn it my way and I'll tell you if you got it right. Right. All kinds of creative spellings. Right. Don't worry, you won't be graded on spelling. Right. Yep. All right. It was the discriminant. And the discriminant is b squared minus 4ac. Notice it's not the square root of. It is b squared minus 4ac. So now, can I just grab a, b, and c off my equation the way it is right now? No, you have to set it equal to 0 first. Everybody do that, please. Move this over to the other side. Now, granted, you could move two things. You know, you could theoretically move this and this over there, but that's two steps. It would be a lot smarter to, and then you're going to have a negative x squared, which is kind of a pain. So I'd recommend you just move that negative 4x to the left. So now you got x squared plus 4x plus 2 equals 0. Would you please find b squared minus 4ac, and then tell me how many solutions does this have? I'm going to pause for a second while you try those. All right, so here's what I think we should do. B squared minus 4ac. B squared minus 4ac. What is b squared? 16 minus 4 times, what's a? 1 times c is 2. And that means 16 minus 8, and that is 8, and I was wrong, and a lot of you were right. 2 solutions, sorry about that. It's 8, and there are 2 solutions. I started with a different problem last hour, I see that now. All right, so that's why I was expecting the answer to be different. I'm going to give you another one, and again, the directions would not be find the discriminant. The directions would be how many solutions does this have? X squared plus 2x equals negative 3. I'll pause while you try that one. All right, and why is it no solutions? Because b squared minus 4ac, first I got to move this over to the other side and make it x squared plus 2x plus 3 equals 0. b squared minus 4ac comes out to be 0. Does that mean that, wait a minute, no it doesn't, my bad, sorry. It comes out to, let me think now, b squared is 4 minus 4 times a was 1 times c is 3, there we go, it comes out to a negative 4 minus 12, which is negative 8, and that means there are no solutions. All right, now, if that answer for b squared minus 4ac had come out to 0, if it would have b squared minus 4ac was 0, then how many solutions would it have? 1. And that one solution would be the what? The vertex. Now think about this. Do you get that parabolas? These are all parabolas. This unit's called quadratics. They're all parabolas. Okay, so if they're all parabolas, they either go like this and don't touch the axis at all, in which case there's no solutions. Or they go like this, in which case they touch and they have how many solutions? Only one solution. And then last, so wait. They have 2 solutions. Sorry, that had 2 solutions. I was trying to read that email that popped up, and I got to stop those emails from popping up. And then touching like that is if there's only one solution. And get how if it's one solution, that one solution is the vertex? Does that make sense? All right. Okay. Next thing I want to talk to you is about range. If I have a parabola like this, would you please write down for me what the range of that parabola is? Your answer should be something like -3 to infinity, or whatever it is. -infinity to 3, or yes, 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 yes. Nope, I fooled you with my number. Yes, I fooled you with my number. Yes, yes, yes. It's not 3. Nope, it's not -2 either. Ah, there we go. Yes, good, good, good. Not a 3. Good, good. It's weird how I put that number into your head by just saying it as an example one, and then everybody thought it was 3. It's not 3. It's 2. And it's not -2, it's +2. 2 to infinity. That's the range of this thing. Wait a minute. I did something slightly wrong, though. If it touches 2, I need a bracket right there. Okay, good. So now, how about this one? What if I just say a parabola has a range of -infinity, I'm drawing that funny, -infinity to 5. And what the heck would that parabola look like? And here's the really, really important thing. What could you tell me about its vertex? Once you have a sketch of the parabola, I think you'll understand what I mean. So your first job is to sketch the parabola. Okay. So hopefully you said, if it's going from -infinity, like we're down in here. So hopefully you knew this, and it's going all the way to -infinity, it must mean that the parabola is generally running like this. Now, could this possibly be the right answer? No, because mine isn't going to +5. So if I grab this parabola and move it up, there, it must be something like that. Now, how many of you had something like that? Okay, good. Now, would you agree that that's over here would still work? And over here would still work. But what do they all have in common? They all have a y value of about 5. Do you get that if I move it over here, for instance, this dot right there is at something, 5? From what I told you, all I told you was a range. You cannot tell what the x is. But you know that at the vertex, the y would have to be 5. All right, let me give you another one. Let's say I give you this equation. Y equals -x squared plus 7. What's its range? I recommend making a sketch, but you don't have to. All I'm asking is, what's its range? I'll give you a hint. Didn't I kind of give you vertex form here, even though it looks funny? It's vertex form. All I did is throw in a +0, which doesn't really do anything, right? And I could tell my vertex is at 0, 7. You know what I mean? So now I can make my sketch over 0, up 7. So I go up 1, 2, 3, 4, 5, 6, 7. And then there's my top, and then there's my parabola, right? No, because it's got a negative in front. What does that mean? Is this parabola going to have a minimum or a maximum if it's got a negative in front like that? It's going to have a maximum. Good. I'm glad you learned that word. There we go. Do I know for sure that the vertex is there? On this problem, I do, because I've got an equation. If I've got an equation, I know everything about it. Okay. How about this? Finish this sentence. The y-intercept is where what? And the x-intercept is where? All right, good. You'll need to know those two also. All right. Next, let's do, again, I'm not going to tell you the process you need to do. I'm just going to say the words. Find me the vertex for this. X squared minus 4x plus 2. Find me the vertex. And no, you shouldn't graph it. There's a much easier way to find the vertex. I'll pause while you do that. Okay, so I'm back. Here we go. I'm going to be doing what's called complete the square. If they say vertex, this is sort of like a car brand, like the Cadillac CTS, the Lexus LS, the what's that new brand that's all electric? It's kind of cool. The Tesla, and they have usually just like a letter. And I think that what's the new Tesla they're just launching? Is it just the S? Model S. Okay. Anyway, the vertex, I want to call this, my brand for my car is going to be the Vertex CTS. Finally figured out how to put that all together. Sort of like the Cadillac. I think that's called a CTX in the Cadillac. But anyway, Vertex CTS. What the heck am I talking about? Complete the square. Okay, whenever you see vertex, I want you to think complete the square. Because if we're not going to tell you complete the square. So you have to know what to do when you want to find a vertex. I've been telling you that since the beginning. I just had these weird trying to find ways to like make it work, and that one works the best for me. Because they're going to say, if they don't say complete the square, they're going to have to say vertex. And if they're asking for the vertex form, you got to be able to say, oh, vertex CTS. So now I do half and square. Half to 4 is 2. 2 squared is 4 plus 4 and a minus 4. And that part factors y equals x minus 2. A lot of people make a plus right there. It needs a minus because of that. Squared. Put that together. Minus 2. Raise your hand if you had that one right. Okay, good. That's the easy kind. Let's move up a notch to the fraction kind. They would say, again, just find the vertex. And it would give you one like this. X squared minus 3x plus 1. This one will have a fraction in it. I'll put the plus 1 over further. I'll pause for a second. Let me try that one. Well, all right, so here we go. I'm going to start by taking half of the 3. Please don't do 1.5. I'm telling you, you can't do that when you change this to like a letter. You won't be able to do a decimal on it. The fractions is the way to go. Learn it with the fractions. If you used a decimal, change it right now to a 3 over 2 because it'll help. I'm telling you, this is not just for my good. It's not for my good at all, in fact. It's for your good. So that's half and then squared. And then I would actually put the exact same thing with a negative in front of it like this. But this part is really critical that you understand. Do you get how some people would think that that comes out positive? Because they'd say, well, I'm squaring it, so it's going to come out positive. Wrong. It has to be negative to balance out this one that's positive. That's the whole point of it. So why mathematically is it not going to turn out to be positive? Because you do the squaring first. See? What's in there has to get squared, and then you can apply the negative to it after the squaring is done. If the negative was on the inside, then it would become positive. All right, so that's really a critical little piece. A lot of people think that turns into a plus right there once you square it. It does not. Y equals x minus 3 halves, quantity squared. Then this part has to be done first, which makes 9/4. Then I'm going to throw the negative on it. Negative 9/4. A lot of people make mistakes, so they try to do too many things at once. Now, if I had an eraser, I would, which I do, change this 1 into 4/4. Why? Because it works so much nicer to have a common denominator like this, right? So now it's negative 9/4 plus 4/4 makes negative 5/4. And I'm going to bring the whole rest of the answer down. Y equals x minus 3 halves squared. There it is. Raise your hand if you had that one right. Okay, that's most of you. If you didn't get it right, then try harder on this next one. We're going to have one more with a fraction in it. You need to understand those. All right, this one is going to have a fraction in it if you do it right. Y equals x squared plus mx minus 1. Mx? Yes, mx. Okay, for those that are stuck, here's some help. First thing, m, I'm supposed to do half n squared. Half of m is a half of m, or an m over 2. Either way works. But then don't forget to square it. And here's the really common screw up. Do you get why that is wrong? Also, this would have been wrong. Because it needs a parenthesis. That's all that, do you get that right the way I wrote it is different than this? Because this one would square both the m and the 2, and this one would only square the m. All right, so if you wrote it this way, it's going to get marked wrong. This way, right. Yes? And m squared over 4 is the same exact thing as that is. See why this one now becomes so obviously wrong if the right answer is really that? This one's wrong. This one's wrong. This one you could put a parenthesis on to make it right. All right, so I'm going to go back up here. I was trying to make a point that a lot of people screw this up because they forget it's half and then squared the whole thing that's been halved. You don't just square the m. You do half m, and then once that's done, in parentheses, you square it. Okay, and then I do the opposite of that, which is minus the same exact thing, 1/2 m. Totally okay if you said m over 2 squared. All right, now this part becomes x plus 1/2 m quantity squared. Okay, because we always take this number right here to put there, the thing that hasn't been squared, or the square root of it. Then this last part is tricky to do in the right order and everything. What has to happen first in math? No, actually, technically parentheses, but then exponents. Okay, good. So then I go 1/2 squared is 1/4 m squared. There, I did the parentheses. Do you get that there's still a negative lurking on the outside? And then minus 1. Now, the nice part about this is I can't actually simplify that further, so that's it. I don't have to get a common denominator and blah, blah, blah. That can't be simplified anymore, so we leave it. So your final answer is that. That is some serious math. Yes? How to get 1/4 m? Because 1/2 squared means 1/2 to the second, which means 1/2 times 1/2, which is 1/4. And then the m squared. That's really critical that you get this. We had the test the other day on pre-calc, and a lot of people put this, and then other people put this. Do you get that they're different? Okay, so when we have a variable, like if you have pi r squared, and then I replace that r with something, do you get how I always put parentheses around it? Because if it's like r turns into 2 h's or something, if you have the parentheses around it because it was a variable, it needs parentheses around that spot. Because if you don't put the parentheses there, if you're just kind of lazy about it, and then you throw in 2h here, you get how that's totally different than that? That would be 4h squared, and that one's only 2h squared, and that would be wrong because you don't have the parentheses and it's not getting done right. Okay, so moral of the story, in that problem we just had, this needed parentheses around the 1/2 because we want to do that first. Half of it first, and then you square it. Okay, so let's move on to some more. This one would be like the hardest of them all. See if we can handle this one. Y equals 3x squared minus 9x plus 2. Why is it so hard? Because you're going to factor out a number, and then you're going to have a fraction also. But the first step's always the same. The plus 2 just moves way over, gives you room to work. Then you factor out the 3. And notice this way, with the plus 2 way over here, I'm not even going to think about factoring the 3 out of that, because you don't. Mr. Q, tell me how to take it to the next level here with this 3 being here. All right, so I'm going to take 3 halves. Perfect. Now, that's half and squared. Quantity squared. I like the way you said that. Perfect. And then if that's plus 3 halves squared, then I also have minus 3 halves squared. All right. Now, this part's the part that factors. Y equals 3. Stop me whenever you need to. X plus 3 halves quantity squared. And then I just have to put all this together, right? Wrong! Come on, somebody's supposed to stop me in there. What have I forgotten to do that's so easy to forget? It's easy. You have to multiply this 3 right here. Has to go also there. And multiply by 3 here. That's so easy to forget. Why? Because this 3 is going to multiply by that one. So it needs to also multiply by this one to keep them balanced with each other. So this multiplied by 3 is the most forgotten thing on this whole test. Okay, whenever we've tested on this stuff in the past, people always forget that step. And I forget that step constantly. Because it's just not natural to remember to grab something from over here and put it all the way over here. All right. Yes?
Would it be okay to write 9/4 instead of 3 halves squared?
Yes, in fact, I'm going to do that right now. 3 halves, I'm going to do the squaring part first because exponents come before anything else after the parentheses. So 3 halves turns into 9/4. Now just don't forget that it's a negative 9/4. And then you have to times it by 3. This times by 3, how do I do that? Where do I put the 3? You wouldn't believe how many kids think you times by 3 by times in the top and the bottom by 3. No, because that's the same as timesing by 1. Get when you times by 3 and over 3, it's just going to cancel out again. So you times by 3 over 1. And we still have this plus 2 to do in a minute. One step at a time. That's the way math is best done. Oh, I had my squared in the wrong spot. Boo. Squared. Sorry, on the outside of the parentheses. And then minus 27 fourths plus 2. Oh, so close. That 2 has to be changed into fourths. I hope you know 2 means 2 over 1. I hope you know to get 4 as a common denominator. That's something we've practiced. How do we get a common denominator here? You times by 4. If it times by 4 here, I got to times by 4 there. That's one of those reasons I have that on the top 20 sheet, because a lot of people came into this year having forgotten how to do common denominators, but now you remember again, I hope. So this is 8/4. Now it can be added to the 27/4. Negative 27 plus an 8. That's like negative 20 plus a 1, negative 19/4. And then y equals 3 times x plus 3 halves. Do you guys ever think about the fact, what I just taught you right there, and what you're able to do right there, that if you, oh, did I do something wrong? What do you think?
Is this supposed to be minus 3 squared? 3 halves.
Oh boy. Okay. Oh, there's a, yes. Oh, so easy to forget that too. There's a minus right there. So this should have been a minus this whole time. Boo. Even I would have got this problem wrong. I'm the math teacher, for Pete's sakes. So, easy mistake to make. Try not to make that one too. I'd say the most common marked wrong part is the end of the number. And I think you get why. There's a lot of fraction stuff to add and whatever. The second most common thing to mark wrong is this. And the third thing is people forget the squared. So watch out for those little things. So look back at your answer. Make sure it looks like it's in vertex form and everything. All right. But I was just going to make the comment that many people off the street cannot do that problem. And I just proved it by not doing it right myself. But if you just walk by the average person on the street, they could not do this. You're doing tough math. That is a tough one in particular. Even moms and dads that have been good at math in the past and usually like helped you when you were little, they couldn't do this. There's no way. Ask somebody to turn us with that one into vertex form, and it's not going to happen. Unless they cheat and graph it and then find the vertex. But then they'd have to be able to doing it on graph paper with decimals because it's going to be awful. So anyway, you've learned something that's challenging. All right. Next topic. You have a question first?
No.
Okay. All right. We've talked about that already, so we're good on that stuff. All right. Sometimes a simplest question can make people just lock up. And here's one that is really very simple, and yet the wording is what messes people up. Solve. Just solve. Would you agree that that's sort of the same as finding the solutions? Would you agree that the solutions are the same as the roots, the x-intercepts? They're all the same. So don't get confused by this. If they ask you to solve it, or to find the x-intercepts, or to get the roots, or to get the zeros, they're all the same thing. So when I say solve, that just means get the roots, get the solutions, get the zeros. And the first thing you have to do is get everything to one side. You could either move these two things over here, but then do you get you to have a negative on the beginning of the problem? It'd be negative 2x squared, and that's a bit of a pain in the butt. So I personally would move this stuff over to the other side. So I'm going to subtract x squared first, and this cancels. Negative 4x equals x squared minus 21. Then I'm going to move this to the other side, so I'm going to add 4x to both sides. 0 equals x squared plus 4x minus 21. Now, try to remember this. You can jump right to the quadratic formula to get all your solutions, your roots, your zeros, but there's a faster way. Remember how to solve this puppy the fast way? Factor it, yeah. And by the way, factoring alone doesn't solve it, but using the zero product property. That's what this is called when you factor it. Because see, you got two things multiplying and equaling 0. That's called the zero product property. So if we say use zero product property, that's what we mean. The product equaling 0. Okay, so by the way, it was x minus and x plus something. And how do I tell what? Well, there's a 7 and a 3 makes a 21, right? And do a 7 and a 3 also somehow make a 4? So you got to be just careful with how you do it. And I think you end up with plus 7 and minus 3. Did I do that right? Okay, and if you wanted to be sure, you just do first outside, inside, last. But I've double checked it. It's right. So then I say x minus 3 equals 0, x equals 3. X plus 7 equals 0, x equals negative 7. Now, why do I take that extra step? Because a lot of kids will by accident say the answers are 7 and negative 3, and they're not. They're 3 and negative 7. All right, one more common mistake. People have this. You're the teacher. Kid writes this. X equals 5, x equals negative 3. Because they're doing it quick in their head. Totally wrong. Do you get what they did wrong? They thought the answer is the opposite of this number. It's not. Okay, it's this part is the right answer, but this part's wrong because what we really have is 2x plus 3 equals 0. 2x equals negative 3. X equals negative 3 halves. I want you to solve one like that, please. X minus 4 and 2x minus 3. Find me your two answers and make sure, just careful about it. You don't just slap down two numbers. Turn it my way and I'll tell you if you did it exactly right. Make sure. Yes. 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 And by the way, what did we just find? Yes. Yes. Solutions. Yes. What else did we find? Yes. 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 What else did we find besides the solutions and the roots? Zeros. Good. 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 And they're also the what's? X-intercepts. Good. Yes. Yes. 4 and 3 halves are the two answers. X equals 4 and x equals y. 2x minus 3 equals 0. 2x equals 3. X equals 3 halves. There we go. All right. Whew, we covered a lot of stuff, but we still aren't done yet. That's why this is a tough test. There's so much to know. All right. What if we had an answer that's in this form? Let's say 5 plus or minus 15 root 3 all over 10. Do you know how to simplify that? Go ahead, simplify that. I hope you know this one. We've been practicing on top 20 long enough. So 5 goes in here, here, and here. 5 goes in here once, 3 times, and twice. 1 plus or minus 3 root 3 all over 2. All right. Let me give you another one that's a little weirder. Negative 5 plus or minus 5 root 5 all over negative 5. Let's see if we can handle that one. Turn it my way. I want to see how many people know what to do in the first place. You're missing a number in front. You're missing a number in front. A lot of people cancel and they just make the number disappear when they cancel it. Don't do that. Yours isn't reduced all the way. You messed up the bottom of yours. Yours isn't reduced all the way. Yours is right, 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 right. Yours needs to go further. Yes, but you can divide by that number on the bottom. Yes, yes. You can divide by that number on the bottom and actually do it. You need to finish it, Mr. B. I think so, yes. It's not a, it's a square root of 5 though, not a, okay. Yes, yes. Okay, let me explain to those at home. Here's what I'm doing. 5 goes into all of these. 5 goes in here once, once, and once. So I could do that. But it'd be even smarter to put negative 5 into everything. Let me show you. Most people are going to do 5. So I'm going to say negative 1 plus or minus 1 root 5, which is root 5, all over negative 1. And then they get stuck. And they're like, I think I should be dividing by 1, but I don't know what to do with the negative. Well, what you're really doing then is you're dividing both this part and that part by negative 1. So negative 1 divided by negative 1 becomes positive 1. Plus and minus. Negative root 5 is what you're going to be tempted to do, but there's no such thing as a plus minus minus. Think about that. On minus is really an opposite of. If you are doing the root 5 and the opposite of root 5, does it help to do the opposite of root 5? It doesn't change anything. There's your final answer. Okay? Notice, I changed this sign. I didn't change that sign. Why? Because it's already got both. It's already got a plus and a minus. When you throw in another minus, it doesn't make any sense. You got a one of a positive, one negative, and that's all you can have. All right. So, next topic. What if we had this? 5 plus or minus square root of 13 all over 6. Could you reconstruct what the problem was originally? Yeah, you could. I talked about this before. Could you try to figure out for me what the problem would have had to have been? Y equals something. I'll give you a hint. Find A and B first. And once you found A and B, you find the C part. It won't be too hard. All right. This is a challenging one, but this is the kind of thing you have to be able to handle to be able to get an A. You're not an A student if you can't handle something like this. You're going to be a B student. All right, I'm going to pause for a second while you try this, and this time I'd like to set up the partners to share at the end and see if you get the same answer. And if you don't, you can help each other. All right? That last part is really important. If you're like, I don't know what to do, just say, can you help me? And then if they know how to do it, they can show you what to do. All right, I'll pause for a second while you try this. Okay, here's what you should have done. This is negative B. This is 2A. Do you get those little equations? So this is really A equals 3. Yay, I got that done. This is really B equals negative 5. Got that done. I solved my 2 little equations. Here's the third equation. The stuff underneath there is B squared minus 4AC. And now I know A and I know B. So I go like this. 13 equals B squared, which is 25, minus 4 times A, which is 3, times C. All I did is stick in my numbers into my formula. Okay, now I got 13 equals 25 minus 8c. Then I subtract 25 from both sides. Negative 12 equals negative 8. Wait a minute, something went wrong there. Not 8c, 12c. Thank you. Thank you. Okay, now I'm going to subtract. So we got negative 12 equals negative 12c, and then c equals 1. And a lot of people forgot. So many people forgot. They just told me a, b, and c. Yes, those are a, b, and c. But your answer is ax squared plus bx plus c. So 3x squared, and b is negative 5x, and then c is plus 1. And there you go. That's another tough one, but doable. All right. And min versus max. I know right away by looking at this thing if this one has a minimum or a maximum. Turn it my way and tell me what you think. All right, pretty much everybody's getting it right. They're saying max. Then how would you prove it? How would you say, because this parabola was reflected. Okay, I'll give you that. It was a reflected parabola. Parabolas normally are like this, and this one's reflected. Okay, so it has to be a max because it's been reflected. The a term, that's technically a right there, right, is what? A is negative 1. All right. All right. So what if I put the negative here? What? How can I get that negative off of there and put it where it's supposed to be? Divide both sides by what? Divide by negative 1, divide by negative 1. And watch what happens. Y equals negative x squared minus 5x. All that happened is everything became the opposite of itself. Negative y turned into positive y. Positive x turned into negative x. And positive 5 turned into negative 5. You can do that on an equation. Change everything to the opposite of itself. It's true if I had like 3 plus 2 equals 5, right? If I make everything the opposite, it's still going to work, right? I can't just change that one, or it won't be true anymore. But if I change that, and that, and that, now it's still true, right? Okay. All right, so why do we do that? Because now I can see there's a negative. It's definitely a flipped over parabola. And if you just made me a sketch and said the parabola looks like this, so therefore it is a max, that would be a way to prove it. Okay. So we've covered a lot of topics. I know that there's more than that even, but I also know there's a limit to how long we have. So your assignment is the worksheet for today, all of them, and check them, please, for your own good. And if you get like 3 wrong, don't just say, well, that's not too bad. Maybe those are the 3. They're going to all be R3s on the test. And if you get all 3 of your R3s wrong, you will get a C on the test. Okay, so study. Do a really good job on this one because this is not an easy test tomorrow. Okay, that's all I got for you for today.